To all. Today, in continuation to the Newton ring topic, I'm interested to discuss some important problems related to the Newton rings. These problems are quite conceptual problems, so it need a proper understanding. So the first problem in this video lecture, we are going to discuss what would happen if the plain glass plate is replaced by a plain mirror. When we place a plain mirror in place of the plain glass plate, the transmitted part get also reflected back. Therefore, we have a uniform illumination. So we get a uniform illumination because the interference caused due to the reflected part of the light and transmitted part of the light must overlap. Both patterns are complementary to each other. Therefore, due to the superposition of the both pattern, average intensity is being observed. Means we observe say uniform illumination, and that is a very important problem. The second one, what would happen if a liquid is introduced between the plano-convex lens and glass plate? By introducing the liquid between the plano-convex lens and the glass plate, a symmetrical liquid wedge-shaped thin film of the refractive index mu is formed. This is between this lower surface of plano-convex lens and upper surface of glass plate. About the contact point, a symmetrical liquid air thin film of a refractive index mu is formed. The diameter of the nth dark ring in case of reflected part of the light is given for a liquid symmetrical wedge-shaped thin film. Probably you may recall the expression for the square of the diameter is equal to dn dash square is equal to 4n lambda dash r, where lambda dash is the wavelength of the light through the liquid, and we have a relation lambda dash is equal to lambda upon refractive index. So the wavelength of the light being reduced, therefore the dn dash square is equal to 4n lambda capital R upon mu, and we know that the dn square is equal to in air is equal to 4n lambda r. By using these relations, we can have the dn dash is inversely proportional to the square root of the refractive index. So the diameter of the nth ring should reduce by a factor of under root mu. Therefore, complete pattern must be reduced or contracted towards the center. Now the third important problem which we are going to discuss with you, what would happen if a plano-convex lens has a small radius of curvature? See, in the Newton ring setup, the radius of curvature of plano-convex lens is small, so the diameter of the nth ring is given by the dn square equals to 4n lambda r. So dn is equal to under root of 4n lambda r. For the nth ring and lambda is constant, the dn is directly proportional to the under root of capital R. R is the radius of curvature. Because it is having a direct proportionality, if R reduces, the dn also reduces. So the complete pattern of the contracted towards the center, and very few fringes are visible. The next important problem is that what would happen if the plano-convex lens is resting on a curved surface glasses. In this case 1, if a plano-convex lens is resting on the plano-concave glass surface, likewise this is the plano-concave surface, and this is your plano-convex lens. Both are having the different radius of curvature. One is having r1, that is plano-convex is having radius of curvature r1, and whereas the radius of curvature of the plane concave surface is r2. Now whenever the such as assembly is formed, a distorted wedge-shaped thin film is enclosed between the lower surface of the plano-convex lens and upper surface of plano-concave surface, which is symmetrical of course, and therefore the interference is being caused by this symmetrical distorted air wedge thin film. If you look at that, the any point the thickness of the film is defined as the T, this one, and we have a reference line which is touching the contact point. So we have a relation for the T and T1 and T2. Remember, the thickness of the film is T, which is continuous increasing from the contact point. At any point, the thickness of the film is T, and the effective part difference of the reflected light is delta effective equals to 2T plus minus lambda by 2. This plus minus lambda by 2 is due to the Stokes reflection, where T is computed as, from the diagram, this is your T, this is your T, and this one is your, from this position to this position it is T2, and from this position to this position it is called T1. So we have T1 minus T2 equals to T. Now the T1 and T2 are computed as a very similar way calculated in the discussion while discussion in the Newton ring formation. So T1 and T2 are computed from the geometry. So T1 is equal to dn square over 8r1 and T2 is equal to dn square over 8r2. So the value of T equals to dn square over 8 bracket 1 by r1 minus 1 by r2. Putting this equation 3 into equation 1, we get the delta effective is equal to dn square over 4 bracket 1 minus r1 1 by r1 minus 1 by r2 bracket close plus minus lambda by 2. This is equation 4. The equation 4 must satisfy the condition of maxima and minima to form the Newton ring. So condition of maxima for the bright ring is delta effective must be equal to n lambda, and for the dark ring that is 2n plus minus 1 lambda by 2 for the dark ring. So calculating, we get the dn square as equation 7 for the bright and dark rings. Above expression can be written as 1 by r1 minus 1 by r2 is equal to 2 bracket 2n plus minus 1 lambda upon dn square for the bright ring and 4n lambda over dn square for dark ring. A very similar expression can be found when a plano-convex lens is resting on the plane glass surface. Sorry, when a plano-convex lens is resting on the plano-convex surface, and the very similar way if we perform the calculation, the effective thickness of the airways thin, distorted airways thin film is T equals to T1 plus T2. See, this is T1 and this is T2. This is the reference line which is passing through from the contact point. So the total thickness of the wedge shape is T1 plus T2, that is T. And the very similar way we computed the value of T1 and T2, substituting the value of T1 and T2 and finding the effective part difference and equating with the condition of maxima and minima, one can have a relation as 1 by r1 plus minus 1 by r2 for the bright ring 2 times of 2n plus minus 1 lambda upon dn square, and for the dark ring 4n lambda upon dn square. I advise to all of you to compute the all detail yourself, and thank you for today.